So for today's quest, we're going to solve some projectile motion problems. So what's the recipe? I always try to give you a recipe to solve any kind of problem. And so we're going to use basically the goal method, but we're going to have to do a couple of extra steps in order to figure things out. So the first thing we need to do for projectile motion is always draw a picture, because we need to know sometimes it doesn't start on the ground, sometimes it does start on the ground. And then once you've drawn the picture, the next step is to break the initial velocity into its x and y components. So those are the first two things you should always do. So whenever you see a projectile motion problem, do those first two steps. Once you've done that, then we can go ahead, and I've got this sort of magic table here to look at, and you can see at the side here I've got 3 questions. So how far does it go? What is its range? So if it's asking that, then you're going to use the range equation. And this range equation, remember, it only works if it lands at the same height at which it took off. So if y final and y initial are the same, you can use that range equation. If not, then what you have to do is over here in the last column, you have to use it. The range is the initial x velocity, which you've just found, times the time that the projectile is in the air. And so that will always work, but you have to find first how long is it in the air. So if the problem asks how long is it in the air, if it lands at the same height at which it took off, then the time that's in the air is just equal to the range, which is easy to find, divided by the initial velocity in the x direction, so the x component of the initial velocity. If it doesn't, then you have to solve the quadratic equation. So y equals y0 plus vy0t minus 1/2 gt squared. So if you know the initial and final heights, you know how fast it's going initially, you know g is 9.8, so then you have to use the quadratic formula, and I'll do an example like this for you to find what time is, and then you can plug your time into this top equation to get how far does it go. How high does it go? Well, there's only one way to find out how high it goes. So when it's at its highest point, the trick is that Vy is equal to 0. So we're going to solve the equations, and you can see down here at the bottom I've got in green the standard equations, and then in the red circle I've got the range equation. So we're going to use the bottommost equation here, that at the top Vy is equal to 0. So Vy equals 0, plug in Vy initial, which we know, and then we can get how high it goes, which is the delta y, the y minus the initial position. Okay, so that's the recipe. So let's go ahead and use the recipe to solve a problem. So I'm going to go over to my whiteboard, and on my whiteboard I've got the sample problem here. Hopefully you can see it. So let me zoom in a bit on it. All right, so my sample problem is we've got a camper who dives from a board that's 2.0 meters above the edge of the swimming pool, and his initial speed is 8.0 meters per second at an angle of 30 degrees above the horizontal. And they ask how long is the diver in the air, so that means time, and how far out into the pool does the diver land, so that means it wants the range. All right, so we want time for part A. Oops. Didn't mean to move that. So we want to get the time for part A, and we want to get the distance x final or range for part B. All right, so what's the recipe? So recipe, first of all, we're going to draw the picture, and we're going to break the velocity into components. So we're going to draw a picture. So let's see, we've got a diving board, got a person standing on the diving board, and they're going to launch themselves up, and they're going to land in the water at the bottom. Draw some water at the bottom. All right, so this is just a sketch. It doesn't have to be an artistic rendition. All right, so we want to know how long is the diver in the air. So what's the time at which he hits the water? And we want to know how far does he go. So we want to know the horizontal distance, the range, or the delta x, which is x minus x0. Okay, so we want to know that. and we want to know the time. And what else do we know? So now we're going to do, remember, gather and organize. So we're going to go and read the problem, and everywhere there's a number in the problem, that tells me something that I know. So he dives from a board that's 2.0 meters above the edge of the swimming pool. So what's that? Well, that is how high he is initially. So that's the y0 is 2.0. So I know my y0. And again, remember, you can look at the units. It's meters, so that tells you it's a distance. So it's either going to be a y or an x. And since it's vertical, it's going to be the y. All right, so he's launched their initial speed of 8 meters per second. That's my v0 at an angle of 30 degrees. So that's my theta 0. So now I'm ready to do my second step in the recipe. The first two things you always do when you solve a projectile motion problem: draw the picture and then break v0 into components, vx0 and vy0. So vx0 is going to be v0 cosine theta, right? And v0 is 8. And we've got cosine of theta is 30. So if I put that in, it's 3.464 meters per second. And you'll notice here I've kept a whole bunch of significant figures. In the problem, each of those numbers, let's see, 2.0 is 2, 8.0 is 2, and 30.0 is 3 significant figures. But I'm going to keep more, and then I'm only going to round off when I get to the final answer for significant figures. Okay, vy0 is going to be v0 sine theta 0. So that's going to be 8 sine of 30. Sine of 30 is a half. So that's going to be exactly 4 meters per second. Okay, so I've got my first two initial steps done that I do for every problem. And then after that, we have to think. So we want to know how long is the diver in the air. So we want to know time. So remember our second row in that table there. To find the time in the air, we either use the range divided by v0x, or we use the quadratic formula. And remember, we can only use the range equation, this magic equation in the red box here. We can only use that if the thing lands at the same height that it took off. But in this case, you see, I've got a diver. He starts off on the diving board and he lands in the pool. So since he doesn't land at the same height he took off, I can't use that equation. So that means I'm going to have to use the quadratic formula. So the quadratic formula, I'm going to plug my numbers in to that middle equation for y. So y equals y0 plus vy0t minus 1/2 g t squared. And we know everything in that equation except for the t, right? So we know y, that's where he lands, is 0. y0 is where he starts off, that's 2 meters. vy0 is 4 meters per second. And then we have t, which we don't know, minus 1/2 g. G is 9.8 times t squared. So I know everything there. I can solve for t using the quadratic equation. So let's put in our numbers. So 0 is equal to 2 plus 4t, and then 1/2 of 9.8 is 4.9, so minus 4.9 t squared. And so remember, the quadratic formula is, if I have at squared plus bt plus c equals 0, then t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. My stylus stopped working for a second there. Okay, so all over 2a. So we need to look at our equation and figure out what's a, what's b, what's c, and then just plug them in there. So let me move up a little bit. So a is the thing in front of the t squared, so it's going to be minus 4.9. B is the thing in front of t, so it's going to be plus 4. And c is just the number, so it's going to be plus 2. So I'm going to put into my equation here, t is equal to negative b, so minus 4 plus or minus the square root of b squared. So 4 squared minus 4 times a, which is negative 4.9, times c, which is 2. And then all of that is going to be divided by 2 times a, which is negative 4.9. And it's important when you do this equation, always make sure that you put in the negative signs, because otherwise you can get the wrong answer. All right, so let's plug that into the calculator. If I plug that into the calculator, let me do a couple of steps here. So I'm going to solve, first of all, what I usually do is I solve for what's inside that square root sign. So I'll say t is equal to negative 4 plus or minus. If I plug those numbers into my calculator, I get the square root of 50 some. And let's make it a little bit shorter. It's the square root, and then the square root ends up to be 7.43. Divided by, in the denominator, I've got 2 times minus 4.9. So that's minus 9.8. And so if I put that into my calculator, I'm going to get 2 solutions. One solution if I use a plus sign, and one solution if I use the minus sign. So if I use the plus sign, I get negative 4 plus 7.43 divided by minus 9.8, which gives me negative 0.35 seconds. And if I do the minus sign, I get my negative 4 minus 7.43 divided by minus 9.8. And I get plus 1.166 seconds. So whenever you solve the quadratic equation, you're always going to get 2 solutions. Which solution is the correct solution? Well, time can't be negative, so we can't use the negative time. So our answer is that the time, how long the diver is in the air, is 1.166 seconds. Okay, so I've got the time. So now I need to find how far out in the pool does the diver land? So what's the range? How far does it go? Well, remember, for the range, if it lands at the same height at which it took off, I can use the red equation. We've already said that's not the case here. If not, then I'm going to use that the distance it travels is the initial velocity in the x direction times the time, which I just solved for. So I'm just going to scroll down to give myself a little bit more room. So we're going to use x equals x0. And if it doesn't tell you in the problem, just assume that x0 is 0. So it just gets rid of it from that equation up there at the top. All right, so it's going to just be vx0 times t. So it's going to be 3.464 meters per second. So again, we solve for vx0 initially. You're always going to need it when you solve the problem. And then times t, 1.166 seconds. And if I plug that in, I get a distance of 4.04 meters. Okay, so I've got my distance and I got my time. So if I'm going to give my final answers for part A, t is equal to, and now I have to worry about significant figures when I give my final number. I've got 2 significant figures as my least number, so I need to round that time to 2 significant figures. So I'm going to say t is equal to 1.2 seconds. And for B, the distance, I've got to round that to 2 significant figures, so the distance is going to be 4.0 meters. You'll notice that when I put my time in to solve for the distance, I use the unrounded version of the time and the unrounded version of the initial velocity. If I'd used the rounded version, if I'd used 3.5 times 1.2, I would have got a much bigger value for the distance. So you always use the unrounded numbers to calculate intermediate values, and then you go ahead and round when you're giving your final answer. Okay, so you need to go and solve some more problems, and so I'm going to start off by giving you a problem. You're going to upload the solution on Canvas. So here we've got a football. It's kicked from the ground. It says assume y0 is 0 with a speed of 15 meters per second at an angle of 30 degrees above the horizontal. And we want to find out what's the maximum height, how far away does it hit the ground, and how long is it in the air. So you're going to use that magic table that I gave you and the recipe, draw a picture, start off by breaking the velocity into components, and then solve for the problem. And once you've figured this out, go ahead and do your homework for this module right away while you remember how to do it. Because all the problems, if you've looked at the example that I just did, and you can do this example, you should be able to do any problem with projectile motion.